You are listening to the show on KJZZ. I'm Lauren Gilger.
And I'm Mark Brodie. An all-female crew of analog astronauts recently ended a 2-week mission in Hawaii called Sensoria 1. The mission was the first done by all women at the High Seas Habitat. That stands for Hawaii Space Exploration Analog and Simulation. Joining me to talk about the mission are two of the women who were a part of it, Sian Proctor and Erin Bonilla. Proctor was Geoscience Officer and Science Communication Officer on the mission. She's also a geoscience professor at South Mountain Community College. Bonilla was Vice Commander and Medical Officer for Sensoria. She's worked at NASA headquarters and just finished her master's degree in adventure education. And Sian, let me start with you. Tell me a bit about this mission you were on. It was basically a simulation of being on Mars, right?
That is correct. The High Seas Habitat was established in 2013, and it's on the Big Island of Hawaii. And the reason why it's located there is because of the Mars-like terrain. The habitat sits at 8,200 feet on the slopes of Mauna Loa, an active volcano. And because the volcanic fields are so young, there's not a lot of vegetation. There's lava tubes. There's all kinds of really interesting geology. And so it's a great place to have a Mars simulation.
So, Erin, what was the point of you all being there? I mean, most people go to Hawaii, maybe stay in a nice hotel. They don't stay, on an active volcano like that.
Right. So the Sensoria Mission is the first of many missions, part of the SENSORIA Program. And the point of the program is to get women at the forefront of space exploration and research. And so our mission, being the first, was to be an all-female crew. And so we were conducting research, doing various art projects. A lot of different programs were going on. But the item that tied everything together was that it was about the female embodied experience.
What is the significance of having, for example, an all-female crew on this kind of mission?
Well, it gives us an opportunity to be learning from each other, working together, supporting other women in the industry. But it gave us an opportunity to see how a crew of all women would work well together. And there's a term that we use, it's called crew cohesion. How well does the crew work together, work through issues that arise, and support each other on their projects?
Was there something in particular that was special about having an all-female crew on a simulation related to Mars as opposed to the moon or really anything else?
Well, I think one of the things is the research on how well women do in space. And there is research to support that an all-women crew might work out better for Mars because we eat less, we weigh less, things like that when you can take into consideration how much it costs to put a program like this together. And so I think when we're thinking about how crew cohesion will work and how we select the right group to take on that big endeavor of going to Mars, it's important to look at all kinds of combinations, all male crew versus all female crew versus a combination of both.
So how well did you all work together?
It was amazing.
Yeah.
I mean, who doesn't want to be around really amazing, high-achieving, smart, driven women who really care about space exploration and how solving for space really helps us solve for Earth?
What were some of the experiments and projects that you were doing related to potential travel to Mars, Erin?
Right. So one of the projects that we worked on, actually Sian and I worked on together, was a collaboration with Embry-Riddle University. And they provided us with these vests they have sensors built into them. They're called the hexoskins. And they read all different types of biometric data. So that the purpose of that was to go out on an extravehicular activity. So in that case, we had to put on full analogs or simulated spacesuits and go outside of the habitat as if we couldn't breathe the air like on Mars, and then perform different activities. Like one of the activities was we took a long hike out and into the lava tubes and explored in the lava tubes. And so the purpose of that study was to track heart rate and step count and velocity, that kind of thing, to make sure that to evaluate crew fatigue in that kind of environment.
What does this area of Hawaii look like?
It's beautiful and desolate at the same time. You're on you can imagine that red color of Mars. Well, these lava flows, they're basaltic lava flows, but over time they start to weather and oxidize, and you can get that same kind of red landscape. Very little vegetation. They have two different types of lava flows, Pohoi and A'a. And is like it sounds, if you fall on it, because you're going to hurt yourself. And the Pohoi is more ropey, more smooth. And it's just beautiful the way the lava fields kind of interact with each other, but form lava tubes and skylights. And so a lava tube is when you have a lava flow and it crusts over at the surface, but underneath it continues to flow, and it will flow all the way until it empties and it leaves a tube. And then the top of the tube at the surface will break through and forming a skylight. So you can actually see these holes in the lava field from space and satellite. And Mars has that same thing. And so when we're going to Mars, we're thinking about using these lava tubes as potential habitats because it will help shield against radiation.
How close to this Martian surface is this area? I mean, I'm sure that it's as close maybe as you can get on Earth, but how close is it actually to what you would find on Mars?
Well, depending on where you land and the amount of weathering and stuff, but geologically it's very close. And so when we're talking about the volcanic processes, they're similar to what has happened on Earth. And so that's why Earth is an analog for Mars. And you can go to these places like the Big Island of Hawaii or Iceland and conduct these experiments.
So, Erin, what was a typical day like for you as part of this?
Well, we would get up and we had a medical check every morning. So we were checking all kinds of different data just to see how things would change throughout the mission. And then we would have breakfast together. Actually, we would have all of our meals together. At first we thought we'd be more fluid about that, but it actually worked out better from a crew cohesion standpoint, that if we could sit down and eat together, we could just talk not about the research, but just daily life. And then we would kind of break off into our different groups, working on our research. Some were collaborative with each other. Some were you had to go off on your own. And then we would meet back together in the evenings to talk about what was coming up the next day.
And how isolated were you? I mean, is this the kind of thing where you're really simulating being on Mars, like no cell phones, no communication with the outside world?
That is correct. We did have communication, but it's delayed. So we had our email, which was delayed 20 minutes. We had to turn in our SIM cards. The day, we go into Mars, you can't have making phone calls or anything like that.
Not good cell service up there, I don't think.
Nope. And then internet access, 90% of the internet was blocked for us. And so we only had, email that was delayed 20 minutes each way. And then some sites that we would call whitelisted that we needed for research purposes.
Have either of you been in situations like that before, where you've been sort of cloistered in a research setting?
Yes, actually, I am a career analog astronaut, I guess you could say, as a hobby. I lived in the very first high seas mission. It was funded by NASA to investigate food strategies for long-duration space flight, and it was a 4-month mission.
Wow.
And so this was my return to high seas mission.
How close do you think we are to being able to land a human being and have them stay for some amount of time on Mars?
That's a hard one to predict because the technology isn't there to protect humans on the journey. So radiation is a real problem.
On the way there, not so much being there, but getting there.
Even there, yeah. So the way there, you're in full exposure to solar radiation. And then when you're in the Martian atmosphere, which is very thin, it's not like Earth where we're protected to a certain extent. You're still in very high exposure. So that's one of the top research areas that NASA is asking for help right now on, is trying to figure out how to protect people on that journey. So timing, it's hard to predict when people will be on Mars. I know NASA right now has a goal to have humans on the moon by 2024. And so I think that's a good first step before we start predicting Mars, because it's going to be kind of the groundwork to get us there.
Well, in terms of the goal of ultimately getting people to Mars, what role do you think the mission that you guys were just involved in plays in sort of the ultimate goal of getting people there?
I think that, when you go to NASA has a website on analogs, and NASA clearly shows that the roadmap to Mars and to some extent the moon, is through analog research. And so they're really keen on looking at what kind of data comes out of this. One of our big ones was looking at the microbiome of not only us as individuals, but the habitat, and how coming into an environment like this, how we change the microbes, but the microbes kind of interact. And so swab samples were taken throughout the habitat and outside of it, but also from our personal bodies. And so you can think about what that research of microbiomes is exploding right now. And so looking at how that impacts people physically, mentally, emotionally, I think that's going to play a role in looking at long-duration spaceflight.
Do either of you have aspirations to go to Mars?
Well, not personally. I'd rather go to the moon. That's kind of especially because of what I said earlier, that we don't have the technology yet to take us to Mars. So I'm a mixture of a realist and an idealist. And so my realism kicks in and I say, no, the moon seems more likely. And that's where all the funds are going right now, to build the ships and eventually the habitats on the moon.
Sian, how about you?
I'm a direct product of Neil Armstrong stepping on the moon. My father worked for NASA at the tracking station on Guam.
Oh, wow.
And I was born 8.5 months after those famous first steps. So I consider myself a celebration baby. And so I'm a moon girl. I would love to go to the moon and be able to see Earth rise.
All right. Sian, Erin, thanks a lot for coming in.
Thank you for having us.
Sian Proctor was Geoscience Officer and Science Communication Officer on the Sensoria Mission. Erin Bonilla was Vice Commander and Medical Officer on the mission.